In some ways, these concepts have become the software DNA of the cloud. Um, they have become such an integral part of how you build and deploy software in the cloud that as a cloud practitioner, you probably cannot escape not knowing these well. So on the left is this traditional notion of an operating system. It's been around for years, right? This notion of multi-programming. For those from a CS background, I suppose you've known this for quite a bit of time now. The hardware is quite powerful, right? The hardware is the CPU and all the IO systems in there. And soon you realize that it's not good enough that I run only one application on my hardware. I want to get more out of it. And so this idea of multi-programming started to emerge, where you have multiple processes running on the same piece of hardware. It's almost like multiplexing the same hardware, right? So one process runs on a CPU for a certain quantum of time, and then the operating system swaps that process out and puts in another process to run, and then swaps that out and puts in another process to run, right? And especially when a process is, say, blocking for IO, for example, right? IO being very slow, when a process blocks for IO, the OS takes an opportunity to swap the process out and put a new one in. But this context switching, as it's called, the swapping in and out, happens so fast that to you as a user, you get an illusion that all these processes or all these programs are sort of running in parallel. You get an illusion of everything is running concurrently. In reality, it often is not. And this is not just the CPU that's being shared, even network, for example, right? So the OS is multiplexing the network. When the traffic comes into your computer, the OS kind of looks up at the port number and says, hey, what process does this packet belong to? And it routes it to the right process. So now people took this thought a little bit forward and said, if we can run multiple processes on an operating system today, and everything today from your phone to your laptop to your PC is doing that, right? Why can't we have a stronger isolation by running multiple operating systems on the same piece of hardware? That's where the idea of virtualization started to emerge, that there is a piece of software called the hypervisor that essentially takes charge of the actual hardware resources and then creates an illusion on the layer higher above to these operating systems. So for example, I could run a Linux instance and a Windows instance, or maybe multiple Linux instances on the same piece of hardware. These are multiple operating systems, often called guest operating systems, and each operating system has their own programs running as well. Now, this is extremely useful in, say, server class hardware, right? Where the hardware is extremely powerful, capable. You want to create better isolation. So maybe one operating system is given to one customer, another operating system instance is given to another customer, and so on. And the OS being such a strong sandbox, that there is a strong isolation between the programs that run there, which also means that you're actually making the most out of your hardware, right? You're allowing for more programs to run in parallel on that same piece of hardware. Now, what happened is, over a period of time, the operating systems also started to give you more better capabilities to isolate processes. The OS started doing stronger process isolation. And then this class of, this layer of software called container engines started to emerge. This is better than virtualization in some ways, only because in the virtualization case, you are running multiple operating systems. Each of them has a full kernel. Each of them has a full process table of its own. Whereas the container engine tends to be much more lightweight, because you literally have one kernel, one running instance of the kernel here at the operating system layer. Now, the reason this is relevant is because almost any and all software that you build for the cloud today gets packaged either as a virtual machine image, right? So an image that contains the operating system and the libraries and your code together, and it runs as a VM, a virtual machine on the cloud, or it gets created as a container image that runs in a container environment in